Welcome to
Nay.
Do it.
Channel Everyone. This is episode 2020-60404. Okay, team. Today we are diving into a paper that tackles a huge, real-world headache for self-driving cars and robot teams. What happens when their senses get messed up? We are talking about collaborative perception and corruption. JJ, can you set the stage for us? What's the dream of multi-agent perception, and why do corruptions turn it into a nightmare?
Absolutely, Isabel. The dream is collective intelligence. Imagine not one but several autonomous vehicles or robots sharing what they see. It's like having eyes on all sides of a building at once. This should give the system a superhuman 360-degree understanding. But the nightmare is that real-world sensors are fragile. A dirty camera lens, heavy rain, a communication delay. These are corruptions. The problem is, current systems often treat these corrupted signals as truth. They try to work with the blurry, noisy data as is, which poisons the whole collaborative effort.
Exactly, it's a critical flaw. They are passively accepting garbage data, which then spreads through the network. The core question the paper addresses is, instead of just fusing corrupted data, can we actively clean it up first? Can we recover the clean scene that should be there before we try to understand it?
I love that. Active recovery versus passive acceptance. So how does their framework, Diff-KD, try to be the cleanup crew? The name has diffusion and knowledge distillation in it.
Right? It's a clever fusion of two powerful ideas. Think of it as a teacher-student setup with a restoration workshop in the middle. The teacher is a powerful, ideal model that sees clean, perfect data during training. The student is the practical model that has to deal with corruptions. Usually, knowledge distillation just tries to make the student mimic the teacher. But here, they add a diffusion model as a restoration module.
This is the key innovation, progressive knowledge distillation or PKD. They don't just transfer knowledge. They use the diffusion process to generate the missing or corrupted information. The student model's corrupted observation is the starting point. Then, step by step, guided by the teacher's knowledge of what a clean, global scene should look like, the diffusion model denoises the local features. It's literally imagining the clean data back into existence, conditioned on the teacher's wisdom.
Whoa, so it's not just filtering noise. It's a generative process, hallucinating the missing pieces in a principled way, using the teacher as a blueprint. But wait, what if your own sensor data is totally unreliable? How do you decide how much to trust your neighbor's data, which might also be corrupted?
Brilliant question. That's their second component, adaptive gated fusion or AGF. After you've done your best to restore your own local view, you need to fuse it with your neighbor's restored views. But not all views are equal. If your own sensor is heavily occluded, you should probably listen more to your neighbor. The AGF module dynamically calculates a trust score, a weight, for each neighbor's data based on how reliable your own current perception is.
It's a smart feedback loop. Your own estimated reliability gates your trust in others. This prevents a highly corrupted agent from blindly trusting another potentially corrupted agent. It makes the collaboration, well, more collaborative and less blindly trusting.
So they tested this under 7 types of corruption. The results must have been dramatic.
State of the art, not just in raw detection accuracy, which was significantly better, but crucially in calibration robustness. That means their system wasn't just more accurate, it was more aware of when it might be wrong. In safety-critical systems, that confidence measure is just as important as the prediction itself.
It's a holistic improvement. By actively restoring semantics and fusing data adaptively, Diff-KD doesn't just fight corruption. It builds a more resilient and self-aware form of collective intelligence. It's a step towards systems that can, in a sense, heal their own perceptions.
That is a powerful idea. Collaborative systems that can recover and adapt. Thank you, Zhang, for breaking down this complex but fascinating paper. And thank you all for watching.
Thank you.
Thank you.